Alright, today we are going to talk about multiplying rational expressions. Okay, this week is going to work a tiny bit different than normal. Okay, we're going to do lesson, practice, then a graded assignment, because the two things that we're going to do back to back here are very, very similar. So we're not going to do a separate graded assignment for each. Okay, we'll do a separate practice for each, but then we'll do a combined graded assignment for these two things on Friday. Okay, so we're going to do multiplying rational expressions, practice that, then dividing rational expressions, practice that, and then a graded assignment over both on Friday. All right. So before we multiply rational expressions, let's do a real quick factoring review. Okay, as I've looked through the factoring graded assignments and then the some of the simplifying rational expressions graded assignments, it seems like a lot of us are still struggling a little bit with factoring. Okay, so there's three different types of factoring that we could see as far as coming up with a binomial times a binomial. Now, what's the first step we should always do, regardless of the type of factoring? What should we always look for first?
GCF.
GCF, right? Okay. So, first thing, okay, if I look here, do I have a GCF between x squared and 9?
Yeah. 3.
Well, there's no 3 here.
Yeah.
Yeah. So this would be a coefficient of 1, right? If there isn't a coefficient there. So,
x plus 1, x minus 1.
right, so there isn't a GCF. We can't take one out here. But this is a difference of squares. So I can just factor this into x plus 3 and x minus 3. Okay? Whenever we see a difference of squares, and what that means is subtraction. Difference means subtraction. And then squares means both of these terms are perfect squares. So x squared is a perfect square, x is a perfect square. I can then factor it like this. How about this one? Okay, first, is there a GCF? No, there is not. 25 and 16 don't have any common factors besides 1. Right? So now let's check to see if this is a difference of squares. Is 25x squared a perfect square?
Yes.
Yes. How about 16?
Yes.
Yes. So this is a difference of squares. How would this factor?
5x plus 4, 5x minus.
Perfect. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Okay, now this only applies, okay, when we've got a perfect square minus a perfect square. On some of the factoring and the simplifying graded assignment that we just did, we had some binomials like this where we were only able to factor by taking out a GCF. Okay, so make sure that you are checking to see whether a binomial, okay, meaning two terms, is actually a difference of squares. Okay, we okay on this? All right. Then the second type of factoring that we might see is a trinomial. What does trinomial mean?
3 terms.
3 terms. Right? So a 3-term polynomial when a equals 1. What's a? What does that mean?
First one.
Yeah, the coefficient on the x squared term. Right? So since there isn't a number there, that means that the coefficient is 1. So how do I factor a trinomial when the leading coefficient is 1?
X factor.
An x factor.
A times c on top and then maybe 7 on the bottom.
Right?
You know what you're doing.
I know what I'm doing.
I know what I'm doing. I just have no page.
So what do I do with this?
You multiply 2 factors that equals 12 that can add up to number 7.
Exactly. We want to find 2 factors that multiply the positive 12 and add to negative 7. That's be both positive.
Oh no.
So if we want them to add to negative
They're
7,
both going to be negative.
exactly, I want both of those to be negative. Okay, negative 3 times negative 4 would be positive 12. Negative 3 plus negative 4 would be negative 7. Now, when my leading coefficient is 1, we can go straight to factors. Right? I can just take these two numbers and say my factors will be x minus 3 and x minus 4. We're done. Okay. So when the leading coefficient is 1, we can go straight to factors. Those are the nice, easier ones. Okay. The final type that we may see is a trinomial when the leading coefficient is not 1. Okay. What do I do here? Right, we still want to set up our x factor. So I multiply 5 and 12, which are my a and c, and put that up top. And put my b down here. So again, I'm looking for two numbers that multiply to 60 that add to 19. Alright, so when we get larger numbers like this, it might not be immediately obvious. Okay, like it was pretty obvious in the last problem that we needed to use 3 and 4 to get to negative 7. But here, it might not be so obvious. Okay, we've got larger numbers, so what do we do here? What's that? Yeah, just list out the factors of 60 until we find a pair that would add or subtract somehow to get 19. So, let's see. We got 1 times 60, 2 and 30, 3 and 20. It seems close, but doesn't look like it. 4 and 15. I think that's the winner. 4 plus 15 is 19. So what do I do with that now? Okay, since my leading coefficient is not 1, I cannot go straight to factors.
You bring down the 5x squared and the 12. And then you break those two factors into x.
Exactly. So this 19x is going to become 4x plus 15x. We're going to use these two numbers that we just found. So I'll say plus 4x plus 15x plus 12. And now we factor by grouping. Okay? Now, be careful. I saw some people just say, that's it, those are the factors.
No, because it's
What's that?
each of them is 5 together.
Well, what we want to do is look for a GCF in each pair. So here, I want to say, well, between 5x squared and 4x, what can I take out of both of those terms? An x. Right? There is no common factor between 5 and 4, so all I can take out is an x. And I would be left with 5x plus 4. How about between 15x and 12?
You can take out a 3.
I can take out a 3. So if I take out a 3, what am I left with here? 5x plus 4. And at this step, we better have the exact same factor here. Okay? So then my final answer, okay, as long as I do end up with the exact same factor here, is that factor, 5x plus 4, times x plus 3. Okay. So whenever this leading coefficient is not 1, we have that extra step. Right? Now remember, okay, the first thing we should always do is look for a GCF. And then after we take out a GCF, or if there is no GCF, then these are the 3 situations that could arise. Okay? Questions? Alright. Let's then review real quick what we just did. Okay, we're going to combine this, go one step further today. So let's make sure, bless you, that we're okay on this idea. Simplify and state restrictions. Okay, so what do I need to do to simplify something like this? What's the first thing I have to do? Yeah, we have to X factor both the top and the bottom. Alright, so I'll come off to the side here. In the numerator, my leading coefficient is 1. So this one should be a little bit easier. Alright, I want two numbers that multiply to negative 16 that add to negative 6. What do we think? Yeah, 2 and 8. And one of them will have to be negative, right? Which one? Yeah, 8 will be negative. And now since my leading coefficient was 1, I can go straight to factors here. So we can say that this is just x plus 2 and x minus 8 over. Now let's factor the denominator. So let's x factor again here. But this time my leading coefficient is not 1. So I will have to factor by grouping. Yep, so in the top, negative 4, 2 times negative 2. 3 down here. So what two numbers multiply to negative 4 and add to 3? Flip it. What two numbers multiply to negative 4 and add to positive 3? It's going to be 4 and 1, which we'll have to have one of them negative, right? 4. 1 will have to be negative. Negative 1 times 4 is negative 4. Negative 1 plus 4 is 3. So here we have to factor by grouping, right? Because this is not 1. So I will say this is 2x squared minus 1x plus 4x minus 2. And group the first two, group the second two. So what's my GCF between 2x squared and negative 1x? Just x. Right? So I'll take out an x. I'm left with 2x minus 1. How about between 4x and negative 2? I can take a 2 out. Right? So I'll have plus 2 times, and I'm left with 2x minus 1.
Is this supposed to be the same one on the paper? Problem.
Is it not? Oh, yeah, it should be the same. Yeah.
I had to do a double take because I thought I was wrong.
Yeah, on your paper, there's a subtraction sign here. Make sure you make it a plus sign. Obviously.
Now I'm just joking. Everybody makes mistakes.
So everything should be opposite on this paper then. What you wrote,
Well, no,
like sign wise.
it probably won't work if this is a subtraction, because we would need. Well, no, I guess it would. We would just make this negative, but it'll probably be easier to follow along if you just make the problem plus sign here. Yeah, I guess that would actually work.
It just wouldn't simplify.
Yeah. So, since these two factors are exactly the same, this factor says 2x minus 1 and x plus 2. So, I can put these two factors down here now. 2x minus 1 and x plus 2. Now what? We're not done yet. We can do a little bit more.
You can cancel out the x plus 2 on the top and bottom.
Yeah, we can cancel out the x plus 2's here because they're the exact same factor. So we just end up with x minus 8 over 2x minus 1.
So if they're like the same, you cancel them both out there.
If we have the exact same factor in the numerator and denominator, cancel them out. So that's the simplified part. Okay, we've completed the simplified part. Now we still have to state our restrictions. How do I do that?
Is it going to be x? No, hold on. You have to write down 2x minus 1 equals 0.
Yeah, so what we're looking at are these two factors in the denominator, right? We have to say neither of these factors can equal 0. So what we want to think is, well, what number that I plug in for x in either of these places would make that factor equal to 0? This one hopefully is obvious. What number here, what plus 2 would be 0? So all we're looking at is this factor, right? So we're just saying, what was it? -2, right? -2 plus 2 would be 0. So we can say x cannot equal -2 because that would make this equal to 0. Now we want to look at our other factor, right? And say x cannot equal what here, okay? This one isn't as obvious, right? So what we can do is, I'll come off to the side here again, and I'm just going to take that factor, 2x minus 1, and say that cannot equal 0. And then I'm just going to solve this simple equation. So I can add 1, get 2x cannot equal 1, so get x by itself, divide by 2, and we get x cannot equal 1/2. So that is my other restriction here. If I were to plug in 1/2, that factor would equal 0. Okay? We just can't have 0 in the denominator. We're not allowed to divide by 0. So my simplified version would be this. X minus 8 over 2x minus 1. X cannot equal 2, and x cannot equal 1/2. Okay, that's my whole answer. Okay, the simplified fraction and the restrictions. Okay, so that's what we were just working on. Okay. Questions on that? All right, let's take it one step further now. Of course. It was not a very good game.
No, it wasn't. They promised us sweet, sweet victory. And
Yeah. Mr. Fach,
Fact
I have a question. Okay, so from over here, you did the 2x minus 1 times x plus 2. How did you get that?
So from this step to this step?
Yeah.
So here, since I have the exact same factors, that's one of the factors in my final answer, and then the other factor is x plus 2.
Oh, I always write down that x plus 2 or like whatever order it is. I always write down that order first.
Oh, that's
And
fine.
then I write down the stuff.
Yeah, you can do it that way. Alright, so let's take a look at multiplying rational expressions. This is basically just a bigger simplifying problem. Okay? Whenever I'm multiplying rational expressions together, first thing I want to do, just like simplifying, is factor everything I see. Okay? There's going to be more to factor, obviously, in problems like this. Okay? So when we do practices and graded assignments, there will be fewer problems on them than what we've had. Okay? Because there's a little more work involved in these problems. But we just want to factor everything. Okay? So I'll start with this 2x squared plus 7x plus 3, and I'll just come off to the side here. I'm going to x factor. So how do I factor this one here? How would I start factoring 2x squared plus 7x plus 3?
Oh, there's no GCS, so you just got an X factor.
Right? First thing we want to do is look for a GCF. There is no GCF between 2, 7, and 3. So let's x factor. So to x factor, multiply a and c, first number and the last number. So 2 times 3 is 6. And put b down here, which is 7. So I want two numbers that multiply to 6, that add to 7. It's going to be 1 and 6. So my leading coefficient is not 1. That means I have to factor by grouping. So this will become 2x squared plus x plus 6x plus 3. So I want to group the first two, group the second two. Look for a GCF. So what's the GCF between 2x squared and x? X. So take out an x. I'm left with 2x plus 1. How am I getting that? How am I getting what I'm left with? Yeah, but like when I take out the GCF, what's happening? How do I know that if I take out an x, here I'm just left with 2x, and if I take out an x here, I'm left with 1.
You gotta think about distribution.
Because math.
Because math.
You gotta think about the distribution with it.
Yeah, so if we think about going backwards, if I take x times 2x, I would get 2x squared, and x times 1, I would get x. We can also say we're dividing. Right? If I do 2x squared divided by x, I would get 2x. X divided by x, I get 1. All right. How about here, between 6x and 3?
3.
I can say, yeah, 3. So 3 times, I would be left with the same thing, right? 2x plus 1. I do have the exact same factor here. So this would become 2x plus 1 times x plus 3. So we'll come over here. Go ahead and jot that down. So this one will become 2x plus 1 and x plus 3. Now, down here, there's nothing to do. Right? I just have x minus 4. So I can just, there's no GCF. I can't x factor that. I'll just leave that as x minus 4. Then up here, I've got x squared minus 16. What can I do with that? What can I do with x squared minus 16? It's the difference of squares. Right? So how does a difference of squares factor?
X plus 8 and x minus
Close.
4.
Good job,
It's
Ryan.
too early.
Yeah, you divided by 2 instead of taking the square roots. Close. Well, we should get x plus 4 and x minus 4. How about in the denominator here? X squared plus 8x plus 15. What can I do with that? Yep, I can x factor this one. There is no GCF, right? So I can come over here and x factor. So 1 times 15 and 8. So I want two numbers that multiply to 15 that add to 8. 3 and 5. And this is, or my leading coefficient is 1. So I can go straight to factors here. So I can just say this will be x plus 3 and x plus 5. Now, when we are multiplying rational expressions, this just becomes one big fraction. Okay? This just becomes one big fraction. And any factors that are common to the numerator and denominator, I can cancel out. So what common factors do we see?
X minus 4.
Yep, x plus 3 and x minus 4. Right, I can cancel all those out. Okay, it doesn't matter that this x minus 4 was in this fraction and this x minus 4 was in this fraction. Whenever I'm multiplying, this just becomes one big fraction. Okay, so what I'm left with then is 2x plus 1 times x plus 4 over x plus 5. And that's it. We're done with the simplifying part. Now we still have to state our restrictions, just like we've been doing. So we want to look at our rational expression before we did any canceling. So I've got 3 factors in my denominator. And remember, we're only looking at the denominator for restrictions. So I'm going to have 3 values that x cannot equal. X cannot equal 4 from this factor.
Negative 3. Negative 5.
Yep. X cannot equal negative 3. X cannot equal negative 5. Okay, remember, we're just trying to look and see what value of x would make this factor negative. What value of x would make this factor negative. Right? And if you, even on factors like this, if you can't see that immediately, what you're doing is just saying x plus 3 cannot equal 0. And then solving that. So I would subtract 3 and get x cannot equal negative 3. Okay? So on some of these, we should be able to just recognize what value would make that equal to 0, but sometimes we won't be able to. Sometimes it'll be a little bit trickier. Okay, so this whole thing is my answer. Simplified fraction and the restrictions.
Bless you.
Thank you. Questions? Do we want to do another one together, or you guys want to try one or two?
Can we do another one?
Sure.
Don't do it.
Alright, let's take a look at this one here. So, I just want to factor everything I see. It doesn't even matter where we start, but I'll start at the top left. Got x squared minus 4. Is there a GCF? No. Is it a difference of squares? Yes, right? If we've got a binomial, that's what we want to check for. And if it's a difference of squares, and it is. X squared is a perfect square, 4 is a perfect square, so how would this factor? Yeah, x minus 2 and x plus 2. How about down here, x squared minus 1? Yeah, this is also a difference of squares. Right? So this would be x minus 1 and x plus 1. Now, how about up here? 3x plus 3. Is there a GCF? Yeah, there's a GCF here. What can I take out of both of those? Take out a 3. So I would be left with x plus 1. Right? And the way we're getting that, okay, we're saying if both of these numbers are divisible by 3, I'm going to write that 3 out front, and then say, well, 3x divided by 3 gets me x. 3 divided by 3 gets me 1. Okay. How about in the denominator, x squared plus 2x? First, is there a GCF? I asked you first.
No, I don't think there is. But there may be. You're giving that look. So yes, there is a GCF.
What is it?
I don't know.
Both of these terms have an x. Right? So I can take an x out of both.
Oh, you can do that.
Yeah. Take an x out of both terms, as long as every term that you're looking at, that you care about, has an x. So what would I be left with if I take an x out of each of these? X plus 2. Now, when we take out the GCF, okay, it's important that we write that GCF out front. I've seen a few people, when we take out a GCF, just get rid of it. We can't do that. We still need to write it out front. Okay, so make sure we're doing that. Now, we've got everything factored. We didn't even have to do any x factoring on that. We had a couple differences of squares, a couple of GCFs. Now, let's just cancel out everything that we can. So what can we cancel out? X plus 2. X plus 1s. So I'm left with that. I still have this 3 and this x minus 2 in the numerator. And then in the denominator, I still have x and x minus 1. So that is my final simplified fraction. Now we need to state our restrictions. And remember, we want to look at the fraction before we canceled anything out to get our restrictions. So I've got 1, 2, 3, 4 different factors here. This x is its own factor. So I'm going to have 4 restrictions here. All right, so let's just go one by one. What value of x here would get me 0? 1, right? 1 minus 1, so x cannot equal 1. How about here? Negative 1, so x cannot equal negative 1. How about this one? X cannot equal 0. Right? Whenever we just have the factor by itself, if we plug in 0, that would make that 0. And how about this one? Negative 2. So, 4 restrictions on this one. Questions? All right, let's take a few minutes here and you guys try the next one.
Okay. What did we do in anatomy last week?
I don't know if someone in here, but I think we missed on the eyeball dissection.
All right, so let's let's take a look at this one up here. Okay, I needed to x factor this top left polynomial. Okay, and I needed to factor by grouping here. And when I did that, I came up with 3x minus 1 times x plus 2. Okay. Then this one is just a single factor, x minus 5, so I left that by itself. Up here, this is a difference of squares, so x plus 5 and x minus 5. And then down here, again, I had to factor by grouping. So when I did that, I got 3x minus 1 and x minus 2. So I put that down here, and then I was able to cancel out my 3x minus 1s and my x minus 5s, and I was left with x plus 2 times x plus 5 over x minus 2. And then I needed my restriction, so I looked at every factor in the denominator here. Here, 5 would make this factor 0. Here, okay, this one's not immediately obvious, so we could set this equal to 0. Say 3x minus 1 cannot equal 0. And solve that, and we would get x cannot equal a third. And then here, get x cannot equal 2. Alright? Feeling okay with these?
Yeah.
Okay, I mean, this is basically the same thing as what we've been doing, just a longer problem, right? We're multiplying two of these together, which just ends up being a huge fraction.
Now tomorrow we'll be practicing.
Tomorrow's going to be practice on this.
And then a lesson after that.
Yeah, right. And then we'll do a graded assignment on Friday that combines those two things.
Bam!
Okay.
Yeah.
Questions? All right, then try one more before you get out of here.
Moses.